Okay, guys, let's solve these problems. The first problem asks us to find the number of branches, nodes, and loops. To identify the parallel and series elements of this circuit. The first circuit is this one. First, we need to identify the number of nodes. So, uh, in order to identify the number of nodes, we need to reduce the circuit or to count the nodes. So these two junctions are connected with a short circuit or a connecting wire. So this can be reduced into one node. Let's say this one, the first node, and also this one is connected with a short circuit, and this is the second node, and the third one is this one. This is the common ground for these four junctions. So this is reduced into the third node. So these circuits have this network topology have three nodes. So the number of branches is just simply counting the number of elements: 1, 2, 3, 4, and 5. So it have 5 branches. So it have 5 branches and 3 nodes. In order to identify the number of loops, so we can use the theorem. The number of branch is equal to the number of loop plus the number of nodes minus 1. So the number of branch is the number of branch is 5. The number and the number of node is 3. So the number of loop will be 3. So there are 3 independent loops: this one, and this one. These are the 3 independent loops. So to identify the number which branches are in parallel and which one is in series, these two branches are in parallel because they have the same two nodes. The first node is this one, and the second node is the node number 3. So if two branches share the same two nodes or connected across the same two nodes, those branches are said to be in parallel. The other parallel elements are these two branches because they share the node 2 and the node 3. So these branches and these branches are not in parallel because they only share this one, not the other node, only one node. So they are not not in parallel and not in series. So this and this one is neither in parallel and nor in series. Okay, let's proceed to the second example. Okay, guys, the second example is this one. So for this circuit topology also we are asked to find the number of nodes, branches, loops, and to identify which of the components are in series and which are in parallel. So let's begin. So as you see, this circuit topology is a little bit complex than the previous one. So first we need to identify, we need to know the number of branches, just the number of branches, simply counting the number of components in the circuit, like this: 1, 2, 3, 4, 5, and 6. So we got 6 6 branches. So this one is simply just the output on the 2 ohm resistor, the output voltage on the 2 ohm resistor, not actually a component or a part of the circuit. So we don't count that part. So to find the node, just we need to reduce the circuit into more simpler forms. Like we need to unite junctions into a single nodes, uh, single nodes. So for example, we begin from this. These two are connected. These two junctions are connected with a short circuit. So we need to reduce them into a single node, like this one. Again, another we have right here, two junctions which are connected. This also a part of this also. These three junctions are simply connected with a short circuit, so we can unite them. Like we also can combine this one. So as the first node, because this point can be united into this one, this also can be united into this one, because they are connected with a short circuit or a connecting wire. So we can unite them into this point. Like this circuit is the minimized or the reduced form of this circuit. So again, the second is this point. This is the second node, and also we have this beginning from this one, and this one. These are the connecting these are also the base, the ground, the base one. So this is also can be reduced into like this. Simply we can reduce them. We can unite them into a single node. Because there is no component or there is no branch, just only a connecting wire. So this is the third node. So as you see, this is the base node. The base node is reduced into this one, the third node. This is the second one. This is the first one into a single node. So this circuit have three nodes. So in order to find the number of loops, we're gonna use the formula. So the formula is B, the number of branch, is equal to the number of loops plus the number of nodes minus 1. So the number of branches, as we counted, it is 6, and the number of loops is the one we are searching for, and the number of node is 3 minus 1, 2. So subtracting 2 from both sides, the number of loop will be 4. So we got 4 independent loops. So to count this loop, this is the second loop, this is the third loop, and this is the fourth loop. These are the 4 independent loops from the circuit. This is the 3 nodes. So in this way we count the number of loops and nodes. This is all for this session. Thank you for your attention. Make sure to subscribe and like this video, and if you have a question you can put it in the comment section. Thank you.